Let's understand atomic number and the mass number. Every atom carries two unique identity marks. Its atomic number, which is represented by Z, and its mass number, which is represented by A. The atomic number Z equals the number of protons in the nucleus, which also equals the number of electrons in a neutral atom. It defines the element. For example, hydrogen will have atomic number 1, sodium will have atomic number 11, and the positive charge of the nucleus arises only because of these protons. The mass number A represents the total number of nucleons, that is A, which is equals to Z, that is protons, plus N, which is neutrons. While Z decides the atom's identity, A tells its overall mass. For example, sodium will have 11 and 23 as the representation of those numbers and has 11 protons and 12 neutrons. Thus, atomic number gives the element's name and the mass number reveals its weight, and both of them together, they form the foundation of atomic structure. Let's understand isobars and isotopes. Every atom is represented by Az, where A is the mass number and Z is the atomic number. Isobars are atoms with the same mass number A but different atomic number Z. For example, C614 and N714 both have mass 14 but different proton counts. Isotopes are atoms with the same atomic number Z but different mass number A. That is, they differ in neutron count. Hydrogen has 3 isotopes: H11 protium, which will have 1 proton, 0 neutron; H12 deuterium, 1 proton, 1 neutron; H13 tritium, 1 proton, 2 neutrons. Other examples are C612, C613, C614, Cl1735, Cl1737. Chemical properties depend on electron. Hence, all isotopes of an element show identical chemical behavior, though they show different physical properties due to mass variation. Now let's talk about drawbacks of Rutherford's model. Rutherford's atomic model resembled a mini solar system. Electrons, they revolve around a dense nucleus like planets around the sun. Though this model explained the presence of a nucleus and empty space, but it faced major theoretical challenges. According to classical mechanics, a charged particle moving in a circular orbit is accelerated. Maxwell's electromagnetic theory states that accelerated charged particles should emit radiations. Hence, an orbiting electron should continuously lose energy and spiral inwards, finally collapse into the nucleus within 10 to the power 8 seconds, making the atom highly unstable. But in real, atoms are stable, and that is contradicting to the model. Moreover, Rutherford's model failed to explain one, which is why electrons they remain stable in specific orbits and how electrons they are distributed around the nucleus or their energy levels. Wave nature of electromagnetic radiations. In the mid-19th century, scientists studying thermal radiations realized that heated bodies they emit energy in the form of electromagnetic waves. The theoretical foundation was laid by James Clerk Maxwell in 1870, who proposed that accelerating charged particles produce oscillating electric and magnetic fields, which travel through space as electromagnetic waves. His theory was later confirmed experimentally by Hendrik Hertz. Now let's understand key features of electromagnetic waves. EM waves consist of oscillating electric and magnetic fields perpendicular to each other and to the direction of propagation. They do not require a medium. They can travel in vacuum. They travel at the speed of light, which is c is equal to 3 multiplied by 10 to the power 8 meter per second in vacuum. They are characterized by wavelength, that is the distance between successive crisps, frequency, which is mu, number of waves passing a point per second. Unit for that is hertz, and they are related by an equation which is c is equal to lambda mu. Electromagnetic spectrum. EM spectrum includes various radiations differing in lambda and mu, from radio waves, infrared, visible light, ultraviolet, to X-rays and gamma rays. Only the visible region is detectable by human eye. Others, they need special instruments. Now let's talk about limitations of wave theory. Wave theory could explain phenomena like diffraction and interference, but it failed to account for several key experimental observations. First one is black-bodied radiation. Emission of EM radiation from a perfectly absorbing body depending on its temperature. Second, photoelectric effect. Ejection of electrons from a metal surface when the light of a suitable frequency strikes it. The third, variation of heat capacity. Specific heat of solids changes with temperature rather than remaining constant as predicted by classical theory. And final, line spectra of atoms. Atoms emit or absorb light only at a specific discrete wavelengths. These observations indicated that energy is not continuous but exchanged in a discrete quantities, known as it's quantized. Planck's quantum theory, 1900. To explain black-body radiation, Max Planck proposed that energy is emitted or absorbed in discrete packets called quanta. He proposed the relation which is E is equal to h nu, where E is the energy of one quantum, nu is the frequency of radiation, and h, which is 6.626 multiplied by 10 to the power minus 34 Js. That is Planck's constant. The key idea was energy can only change in multiples of h nu, like steps in a staircase, where it can start from 0 to h nu, 2h nu, 3h nu, 4h nu, 5h nu, etc. and etc. Planck's theory successfully explained this pattern, making the birth of quantum theory and revealing the particle nature of light in specific phenomena. If you want to master this concept with detailed MCQs, comprehensive subject notes, and in-depth explanations, do not forget to visit ResearchGoal. There, you will find this topic structured as a mini course. Complete that course with all resources in one place, exclusive video lessons where I'll explain MCQ step by step, an MCQ-based exam to test your understanding, and a course completion certificate to boost your confidence. These courses are designed to help you build clarity, gain confidence, and achieve high ranks in your exams, all at a very, very affordable price. Enroll on ResearchGoal today and take the next step towards success.